All right, we got f of x equals x squared minus 3. So what I'm going to do is I'm going to look at the graph of this. So I've got y equals x squared minus 3. And when I graph it, I get that. And I don't know why I have a red and a green dot on it. Could possibly be. But let's zoom in a little bit. Let's change our window up. Let's go with -5 to 5 on both. And graph. I'm sorry, that didn't work. Well, it did to a certain extent. We've got that up there, and it's going to be somewhere around 1.7. We're just going to guess 1.7. Okay? Again, there's 1 and there's 2, so it's between the two. And it looks like it's a little closer to 2 than it is to 1. So we're going to pick 1.7, okay? So we want to know what is f of 1.7. So it's going to be 1.7 squared minus 3, which we're going to do this with our calculator because we don't have anything else to do. And we get negative 0.11. Are y'all getting that? Not really?
Okay.
Okay.
I have a question.
Go ahead.
You put that in your calculator, you look and you see what is on the 0, right? Then that's how you got 1.7?
Yeah, it looks like it crosses somewhere close to 1.7.
Alright.
Oh, that's really kind of bright.
Thank you. Now, this will be my x value. And you did?
Yes.
Okay. This will be my x value and this will be my y value. So now I just need to know my slope here. Well, how do I do that? Very good. F prime of x equals to 2 times 1.7. I guess I should say f prime of 1.7 equals to 2 times 1.7. And what do I get there? 3.4. Thank you. So I've got a slope of 3.4, and I've got the point 1.7 and negative 0.11.
Wait, I have a question. So your y value is negative 0.11?
Yes.
Wait.
Go ahead.
I thought f of x had to equal 0.
No, we would love for it to,
So why can't you just put 1.5 or whatever?
because I don't know the exact. That's what we're trying to find. We're trying to figure out what x value will give us 0. And I thought it might be 1.7. But it's not 1.7. 1.7 gives us a number that's close to 0, but not exactly 0.
Okay.
Does that make sense now?
I mean, kind of, but why can't you just look at the equation and put in the square root of 3?
Yes, we could. Thank you. But I want to give us a problem that... Trying to give us an easier problem that can't be solved as a quadratic. I mean, this one can be solved as a quadratic, but I'm trying to give us an easier problem to work with first before we get into a more challenging problem.
I mean, I guess I just don't understand, like, what the point is of all this. Like, what am I looking for?
Again, without saying x squared equals to the square root of 3 plus or minus, without saying that, what we're trying to do here is we're trying to figure out what x value gives us a y value. I'm sorry, what x value gives us a y value of 0. But we're not going to use that method of setting it equal to 0. Because while we can do that with any quadratic, we can do that as long as there's a real root. But in this case, in the case of a cubic, there might not be a situation where we have a rational root. So this will help us to be able to approximate an irrational root for something like a cubic, which there is no cubic formula for us to solve. Does that make sense?
Kind of.
All right, getting better. Go ahead.
So we're trying to. The answer that we get is always going to be approximate because, like, the answer in this situation.
Yeah, we're going to get approximate answers.
So the answer in this case would be 1.7, right?
No. Okay. Yeah. The x value answer for this will be 1.7, but we're going to want to get closer in than just 1.7.
But the answer, what we're looking for is an x value.
Yes.
Okay. So since we picked 1.7, that's approximate.
Yeah.
But we're just trying to keep.
Yeah. We're going to keep going until we get a closer approximate.
So in what case would the answer, because the answer is never going to be exact, it's always an approximate. Approximation?
We generally want to stop that within that 1/1000th.
Move up to death.
Thank you. We want to stop somewhere close to 1/1000th. And the way we know that is we get two consecutive answers that are going to be within that 1/1000th. You good with that?
Alright, so we've got 3.4. What are we going to do now?
Well, we were going to put that in the equation of our line because we're going to construct a tangent line out of this. And to construct that tangent line, again, it's going to be m, which is 3.4 times x minus 1.7 equals, again, what y value is it that we're interested in? 0. So it's going to be 0 minus negative 0.11, which will just be 0.11. So we solve this out for x, so we get 3.4x minus 5.78, thank you, equals 0.11. So 3.4, y'all can't see that. Y'all get to see my legs move again. 3.4x equals 5.89. I'm writing on the actual table. Yes.
That 0.11 was the negative.
Yeah, but it's y minus that, so it's y minus negative, so it becomes positive.
Okay.
So I have 3.89 divided by, 5.89.
1.73.
I get 1.73, okay? So that's my new approximate. And again, you see it's very close to 1.7. 1.7 was a pretty close answer, but this should be just a little bit closer.
What did you plug that into?
Yeah.
What did I plug what into?
Like, what's the equation that you're using?
And
Right here,
Yeah, like, what's
that's the equation of a line. That's m equals x minus x sub 1. M times x minus x sub 1 equals y minus y sub 1.
so
And if you look, just one second. If you look Newton's formula up in a book, they give you a long complex formula. Well, not a long complex formula. They give you a different formula. But to me, it's kind of tedious to memorize when you can get anything from it just using this formula here. All right, Daisy, what?
so what happens now? Like, is that our answer or?
No, we're gonna use this new answer.
Okay.
Go back to the original.
Don't we have to pull it out another decimal place so we know?
Say that again.
Don't we have to pull it out another decimal place so we know that if it's...
Oh, okay. Let's carry this to 4 decimal places. So what was it to 4 decimal places? I just assumed that this was rounded, but I guess it's not. I mean, this was, what is it? 1.7 what?
7324.
1.7324. Okay, thank you. All right, are we good now? All right. So now we want to know what is,
Do you plug that back into the function? You get a y value?
yeah, what is,
F of 1.7324.
yeah.
We're
plug it back to the original, not the derivative. Right?
That is correct. But we're also going to have to plug it into the derivative to figure out the slope at that point
That's true.
Why do you get the slope?
for the equation of the line.
So once you get to a point that's within, once you get a y value that's within that range that we just said, you wouldn't need to find the slope.
All right, so I'm going to plug in 1.7324 and square it and subtract 3. All right, someone's doing this at home. Tell me what your answer is.
Well,